Now we wrote our first bit of JavaScript code that was executed with Node.js. But of course, this code is not too impressive. We could have executed that same code in the browser as well, if we would have added this into a JavaScript file that is then included in an HTML file with help of the script element. Basically what we did before. But of course, the idea now is that we do write some code that executes on a server, because it then, as a next step, might do useful things for us there that can't be done in a browser, like store user input in a database or generate some dynamic HTML code. I outlined all the reasons for having server-side code over the last lectures and sections. And therefore, to get there step by step and to get started, let's now actually write some JavaScript code that can be executed with Node.js that will then actually send a response to a browser, so that will be responsible for showing something on the screen. And for this, we need to use Node.js and the JavaScript code we execute with it to build a web server on our own. Now, that's where things can get tricky to wrap your head around. We did already host a basic website on a drag and drop static site host way earlier in the course. We used Netlify drop there, if you remember. Now there we used a hosting provider that created a web server and hosted our files for us. And during development, we used this Visual Studio Code extension, the live server, to have this auto-reloading experience where we also served our HTML files with that development server. And under the hood, that also was a pre-configured server running on our machine that was accepting requests and sending back our HTML files as responses. That is what this extension did under the hood. Now that we'll write our own so-called server-side code using that extension, or deploying our page on a service like Netlify Drop, which gives us a pre-configured web server, will no longer be an option. Because if we want to execute our own code that executes on that remote machine, on that server, then we also have to write the server itself ourselves. And that might sound very complex, but thankfully Node.js makes that simple. As a side note, I'm often saying server-side code, even though over the next minutes we'll write our own basic web server with Node.js. Still, I always mean the code that runs on a remote machine, which, once you deployed your application, would be exposed to the World Wide Web and which would handle incoming requests from your visitors. Now, that's what we now need to write ourselves with Node.js, so that we then, in a second step, can have full control over how requests are parsed, which data is extracted, and which data is sent back as a response. Because we no longer just want to send back HTML files automatically. The idea of using Node.js is that we have more control than we did before over what happens on that server. Now for that, we will use certain features that are built into Node.js. You might recall this documentation. I mentioned that Node.js comes with a lot of packages that expose different features that you can then use in your Node.js code. For example, Node.js comes with a HTTP package that gives us certain functionalities that we can use in our code to listen to incoming requests and to send back responses. And that is what we need to do if we want to write our own web server. We need to write some JavaScript code that knows how to deal with incoming requests and that knows how to then send back a response, so that we then can send requests in a second step to that custom written web server with help of a browser. So therefore, back in app.js, we will now start by using that built-in package that helps us with that. And we do this in our JavaScript file by using a special keyword, a special function that's built into Node.js called require. We execute this as a function by adding parentheses after its name. And then to require, we pass a string. And that string now contains the package name that's built into Node.js that we want to use here. And in this case, this will be the HTTP package, which is a package for which you can view the documentation as well, that offers certain functionalities that help you deal with requests and responses. So for this, we require HTTP, and calling this function will then return an object full of utility methods and properties provided by Node.js. So we store this object in a constant now, and I'll name this constant HTTP, but this name is up to you. We could also turn it into a variable, but I don't plan on reassigning this to a different value, and hence I can use a constant instead. And these are all features we learned about before. The only new thing here is the require keyword, this function which is built into Node.js. Now with that, we are pulling in this HTTP object, which is full of extra functionality. And we can now use one of the built-in methods. And for this, we use HTTP now. And here we can actually execute the create server method. And this does what the name implies. It will create a web server. So even though we'll now not use some external company's pre-configured web server, we can still easily set up a custom server with help of Node.js. Now, just as a side note, if we would want to host our Node.js driven website, we would still reach out to an external hosting provider and upload our code to them. The only difference would be that we don't use a simple drag and drop hosting provider, but instead we need a hosting provider that offers us a computer that already has Node.js pre-installed. But we will come back to deploying and hosting Node.js-driven websites later. For the moment, let's focus on the code here. And here we do now create a server by executing this create server method here, which exists on this HTTP object, which we do require here. Now, create server returns us an object which has all this server functionality that is required under the hood built in. And we can now store that in another constant or variable, which I will call server here. Now on that server that was created for us, we can now call the built-in listen method. And the idea here is that we first create a server that knows how to handle incoming requests and send back responses. And then in the next step, we start listening on a so-called port number. Now that's a new concept, and for that, let me quickly talk about addresses which we can enter in the browser to reach a website. We can enter something like Amazon.com, that's what we saw before. And this will then send a request to Amazon's servers or server, which then returns the website. Now, when working with a network, which is what we do when we do send requests, then we also have the concept of ports. And every computer has different ports, which are basically entry points to that computer, that are either opened or closed. Now, by default, for most computers, most ports are closed by default for security reasons, because you want to have as little entry points as possible. Now, when you send a request to Amazon.com, by default you send that to port 80, which can also be expressed by adding a colon after this name, and then 80 here. Now, actually, by default, you typically use 443 to be precise, because that uses SSL, which sends the request in an encrypted, secure way, but 80 is also a common port to send an unencrypted request. And you can test this on your own. If you enter Amazon.com:80 and you hit enter, you will see that you still visit Amazon.com. If you would instead enter Amazon.com:100, it would fail instead. So this really works, and this port concept is important. Now 80 is the default, which is why you don't have to enter it. Instead, if you just enter Amazon.com, it's basically sending this to port 80 or 443 to be precise, as I mentioned, by default. The browser adds that port for you under the hood, so to say. But when working with Node.js and creating your own server, you need to let Node.js know on which port you want to listen for incoming requests. And for this to listen, we pass such a port number as a first parameter value. Now, by default, we often use something like 3000 here. That is a port which is typically not opened, but during development, for playing around with our server and testing whether everything works, we typically want to use such a non-default port so that we don't clash with any other services that might be running on our local development machine. That's why we pass 3000 as a number to listen to tell Node.js that once this code executes, we want to create a server and we want to listen to incoming requests on port 3000. If we would then later deploy this code and move it onto a real remote machine, which we rented from some hosting provider, we would swap this for 80 or 443 instead, basically. But for development, we can use something like 3000. And that was a lot of talking about creating such a server and listening, but it is super important that you do understand what this code does. Because if you don't understand that, understanding the other concepts will be very, very hard. Now with that, we are creating a server and we are listening, but this server won't be finished yet. Because whilst it will be a valid server that's created here, this server has no instructions for what to do if an actual request reaches it. We don't define what our response should be or if we maybe want to extract some data from the incoming request. And the entire reason for using a server-side language like Node.js is that we want to have more control and that we maybe want to extract some data from the incoming request. And therefore, as a next step, let's now see how we can add more instructions here.